What was it? I don't have another test here.
Problem 7. Verify the inequality.
Okay, so we have the integral from 0 to 1 from v to the x cosine x. Please put in a dx. I forgot to put it in. Less than or equal to e minus 1. Perfect. For any x, I don't care what x is, cosine is a number between -1 and 1. I'm multiplying by a positive number, which is e to the x. Which is an increasing number. If you remember, Ian, what happened with the cosine when it was decreasing? The inequality had to be switched because the function was, but e to the x is an increasing function. So I can multiply all three sides by e to the x and not switch the symbols. So negative e to the x less than or equal to e to the x, cosine less than or equal to e to the x. I'm going to drop this part because there is no need. So now I have a function less than or equal to another function. I can integrate. There is one property that allows me to do that. The integral from 0 to 1 from e to the x cosine x dx less than or equal to the integral from 0 to 1 e to the x dx. So far so good? So now I can, no problem, I can evaluate this. So what function prime is e to the x? It's e to the x from 0 to 1. When I plug in 1, I get e, minus when I plug in 0, I get 1. Very good. Anything else?
So you can integrate both sides of it?
Yes, as long as I have, just one second. So if I know this, if I show this, which I did, then the integral from a to b from f of x dx is the integral less than or equal to the integral from a to b from g of x dx. This is one of the properties of the definite integral. Yes, Anthony? Sorry.
I wrote, instead of multiplying it right away, I wrote the cosine range and the e range, and then I did them together.
I have to look at it at the end, but this is the way we have to show it.
Okay.
But I can take a look at it. Good. Anything else?
Can we go over number 1?
Yes. What does it say?
Particles moving with the given data. Find the position of the particle. Acceleration of t, a of t equals 10 sine t plus 3 cosine t. Okay, and then we have two other givens. We know that s of 0 equals 0. And we know that s of 2 pi equals 12.
Good. Very good. So, first of all, I have to determine the velocity. Which function prime is 10 sine t? Well, it's negative 10 cosine t. Which function prime is 3 cosine t? So it's plus 3 sine t plus a constant c1. Now I go to s of t, which is negative 10 sine t.
Wait, I thought s of t would, I thought s of t would be the speed. So the acceleration was second derivative, speed was first derivative, and then what some other thing?
It's the integral. Because when I differentiate s, I get v. When I differentiate v, I get a. The velocity is the derivative of distance. The rate of change of time with respect of distance with respect to time is velocity.
I was taking s as the velocity.
Okay.
That's how I did it.
You can't. You cannot jump from the acceleration directly to the distance.
I didn't. I did acceleration. I turned that into the velocity, which I called s of t, but I plugged in these values as if that was for.
But you can't do that.
Why?
Because you are given the values for the distance.
Yeah, but it doesn't say that for the distance.
It's s.
How am I supposed to know s is distance?
Oh, because we always used s for distance.
That's all.
And we always used A for acceleration and V for velocity.
I was not aware of this.
It's one of these weird
That's okay.
things about the sciences that they use the same function name over and over.
Because we don't want DD,
Yeah, I was
the
thinking.
derivative of D.
I was thinking S is
Yeah.
speed, so that means
Because of the Leibniz
Like that.
notation.
Y.
See,
First.
if I have dy over dt is
I feel like
one
that should
thing,
almost
but
be
then
less
dd
weight
over
told
dt
goes
would be
something
a
than
crash.
the other.
So that's why we don't want to use d for distance.
I mean,
We do in pre-calc, but not in calc. Should I continue or not?
No, that was the only thing is I misinterpreted that was supposed to mean that. I didn't know that SFT is always
Okay.
distance.
Is there anything else I need to go back to from the test? So I did write solutions, of course. I did not post them yet because, as I said, I gave Brianna a few more days, but
There's
now I will post them.
Can we
Yes.
go on C?
Yes, see from,
Or it's the antiderivative of e to the u over 1
you mean the
plus
integral.
the integral
Yes?
of e to the u over 1 plus e to the u, and it's all squared.
Very good. So if I say let y be 1 plus e to u, then dy equals e to u du. And this is what I have. So this is the integral from dy over y squared. Which function prime is 1 over y squared? Please remember this one is very important. Is negative 1 over y. So if I differentiate this, I get 1 over y squared. So I have to continue and replace negative 1 over e to u plus 1 or 1 plus e to u plus a constant c. Now if you differentiate this, you will get this. Now if you want to check, you can tell me if you want what you got, and when I differentiate this, you will see it will not equal e to u over 1 plus e to u squared. You can check. You don't have to do it now. So put this that you obtained as an answer, differentiate it, and you will see you will not get the function. Better? Okay. Now, when I differentiate 5,
Only Bree can do it. Ask me to throw.
when I differentiate e to x, what do I get? When I differentiate e to a function u, what do I get? Yes, or u prime. Perfect. But when I differentiate 5 to x, what do I get?
5x times ln of 5 times the derivative of x.
Yes, if it's a function. Perfect. So then when I integrate 5 to dx, what do I get?
5 cx divided by ln of 5.
Very good.
Why isn't
I
it?
remember that now, but
Why isn't it 5 to the x times ln 5?
Because first of all, you have to divide both sides by this if you want to, and then you can integrate. Or okay, that's okay. Let's say prove this. If I differentiate the left hand side, what do I get? Exactly. Now if I differentiate this is a constant. 1 over natural log 5. How much is 5 to the x prime? How much is the constant prime? So 5 to the x equals 5 to the x.
it's constant.
Okay, next question. Is there anything else from the test that you would like to go back to?
the bonus question.
Yes.
So after that equals the integral from 2x squared to tangent x. T squared over 1 plus t dt.
Perfect. if you remember, we know this. We know that that an integral can be presented, we know that a function can be presented as an integral. How do I know that this is a function? I know it's a function because it depends on x. If x is 1, I get a number. If x is 2, I get a number. If x is 3, I get a different number. And so that's why I know that this is a function. When I differentiate the left-hand side, what do I get? Exactly. This is it. However, this is a little bit tricky. I have to have a constant at the lower limit. This one does not have a constant at the lower limit. But there is a property of the definite integral that says from 2x squared to blah plus from blah to tangent x. So I can break it up into two pieces. And this is what I'm going to do. So I'm going to write the integral from 2x squared to blah of t squared over 1 plus t dt plus the integral from blah to tangent x from t squared over 1 plus t dt. So far, so good? Now I'm applying, this is ready, but this is not ready. But I am allowed to reverse, but put a minus in front. One of the properties allows us to do that, but I have to put minus. So from blah to 2x squared t squared over 1 plus t dt plus from blah to tangent x t squared over 1 plus t dt. Now I'm ready to find the derivative of this function. And I'm applying the derivative here and the derivative here because when I differentiate a sum of two functions, that's how I differentiate, right? I differentiate the first function and then the second function. However, coming back here for a moment, if this is a function of x, then here I have to multiply by u prime of x. If it is plain x, x prime is 1, and I don't have to do that. So in both situations, I have a function. So f prime will be negative. I replace 2x squared over 1 plus 2x squared, but times u prime, which will be 4x, plus tangent squared over 1 plus tangent x multiplied by tangent prime, which is secant squared. Yes, you can just play with it a little bit. Square this as 4x to the 4th times 4, 16x to the 5th.
So you can make it more compact.
Yes. Okay, can we start the review now?
But we can just leave it there on the test at that point.
I would not do anything to this, but I would simplify here. I would.
Because we were just asked to differentiate.
Yes, but I will simplify that algebraically to write in 16x to the 5th. Better? Okay. Is there anything from chapter 5 that you would like to go back to?
Did we do integration by parts?
Integration by parts with pleasure, but integration by parts is in Calc 2.
When I was studying, I accidentally went on some stuff for integration by parts, and I was very confused. This.
It's very easy. The way it is in the book, I think it's complicated.
The funny part about it.
I think so. I think there is nothing's easy in the book.
The funny part about it is
That's what the teacher writes her own book and passes out.
Be sure you're in textbook, and then everyone will understand that.
It's hard to put math in words, though. It's hard to put math in words.
All right, but
So that I can give it to you, hey, read it at home and do it. I think.
integration by parts in one of the books that I was using for review and studying was sandwiched in between the topics that I needed. And so I kept stumbling through integration by parts, trying to find stuff.
Well, let's not use a lot of time on this, but I can explain how that works, and you don't have to look at this for a moment. If I have a product of two functions and I differentiate it, what do I get?
G plus F.
Very good. Now I'm going to integrate both sides. Of course, dx. Okay, what do I get here?
F times J.
Oh, very good. And this is the integral from f prime g dx plus f g prime dx. Which one you want to solve for? It doesn't matter.
Let's go with second.
Okay, that's fine. It doesn't matter. It's the same thing. So 5. So the integral from fg prime dx equals fg. I move this to the other side minus the integral from f prime g dx. Do you agree with this?
Yes.
Okay, and now I'm going to choose a problem and
Simple algebra.
Wait, why?
say it again.
Why is that the integration?
I'm sorry?
Why does it equal that?
This one here.
No, below that.
How did you get from there?
So I solved for this.
No, below.
I solved for this,
Oh, you just
moving this to the other side.
She flipped this
Yeah,
side.
So
of the equation.
fg
Okay.
minus this.
I thought we were solving it just using that.
No, so from here we got this. And now I'm going to choose a problem.
It does mess people up when the notation gets flipped.
Yeah.
I'm looking on page 468. You don't need to.
I've lost my dad once before.
Yeah, so this is a typical problem. So let's say 12. The integral from p to the 5th natural log p dp. Okay? Just one problem because I want to review. It doesn't matter if you write it, I hope you agree, as p to the 5th times natural log or natural log times p to the 5th. Would you agree?
Yeah.
Okay. Which of these two functions I can find a function that I differentiate to get that? This is impossible. You cannot tell me I have this whose derivative is natural log p. But I do have a function whose derivative is p to the 5th.
Yes.
What is it?
And that's p to the 6 over 6.
Would you agree that this is the same with that? Okay, very good. So then, f is this. G is this. Now give me the rest. Tell me what to write. You have to give me fg.
And P times G to the 6
Right,
over 6.
so it's p to the 6 over 6 natural log p. I'm done with this. Now minus.
Integral of P to the 6 divided by 6 LP. Well,
I have to differentiate it now. So this is my g, and now I have to differentiate natural log.
Natural log.
Sorry, the being source of this.
Yes. So this is p to the 6 over 6 natural log p. I simplify 1 over 6 outside. I have p to the 5th. So it's p to the 6 over 6 plus a constant c. And you just multiply these two and get 36.
That's cool.
That's all you need to do. This, a proof or simplifying and finding dx and dy and dz, and that's on 3 pages.
That's beautiful math right there. Despite the general feeling of doubt.
Okay, So, do we need anything from chapter 5? Are we okay with the properties? Integrating, the substitution, Riemann sum, finding the approximation for the sign. I saw it in one test. Even if you torture me, I will not remember which one. But I think you had your calculator. I think you had your calculator in degree mode instead of radian mode. Okay? So be careful with that. The midpoint rule, which approximates integrals that we cannot find the antiderivative for. A Riemann sum, integrals, properties. Is there anything from chapter 5, or can I go back to chapter 4? Between now and the final exam, please print out all tests with solutions, quizzes, homework, and go over everything 10 times if you need to.
It's funny, we went through like a ream and a half of paper when I did that.
So, can I go back to chapter 4?
Could we do properties?
Yes, we just had, this was one property. We just had it.
Oh, the properties of the functions
Of the
inside the
antiderivative. The properties of definite integral.
Okay.
So, can we go back to chapter 4?
Wow.
Okay. Chapter 4. What do we should expect from chapter 4?
Review.
So, graphs. I will ask you to graph a function presenting everything. First derivative, second derivative, and everything about the function. Are we ready for one problem like that? Okay, very good. I'm going to choose 22. If we did this problem, 1 minus x squared. Okay, 7 minutes. Everything. Domain. X and Y intercepts. Limits. Asymptotes.
How do you do horizontal?
First derivative. Second derivative. Studying everything about the second derivative and the first derivative.
How do
Yes.
you do horizontal asymptotes?
You find limits at infinity. Find the limit as x approaches infinity and the limit as x approaches negative infinity.
And if they are the same, it's a horizontal asymptote.
They don't have to be the same. The function can have y equals 2, an asymptote at one side, and y equals negative 2 at the other side. They don't have to be the same.
Okay.
But if they are numbers, they are horizontal asymptotes.
If they're defined.
If they are infinities, then there is no horizontal asymptote.
Okay.
So, no, this is not recommended to put in the graphing calculator first. But, okay. So I'm going to ask step by step. Make sure we are all on the same track. What do I have to find?
You just picked the right time to do that, didn't you? So you spent all this time. You got here 7 minutes early. He's not buying.
Have you ever considered playing the grumpy neighbor?
He's gonna, he's gonna finish all his box of pencils.
What?
I'll agree with what was on the teacher's mind.
Well, one of these, you had to pick this day to mow your lawn. You knew any other day of the week you could have mown your lawn, but today I had a block party. You had to pick this day to mow the lawn, did you?
Oh no, the teacher was like, oh, we're 7 minutes early.
Gentlemen, how do we start? What is the first step?
Take the derivative.
Take the
I
derivative
have to
and
find
double.
the domain, please.
Well,
Yes.
You have to start the domain.
Yes, please.
Well, from negative infinity
equals
to
1.
negative 1.
That's a
Negative 1
So
to 1.
first of all, I recommend you do this. X divided by negative x squared plus 1. And then negative x over x squared minus 1. And then negative x over x plus 1, x minus 1. This is the starting point. in which we identify the values of x that make the denominator 0, which means the function undefined. Number 2, here I can already say that the function is odd or even. It's not even because, yes, because when I replace x by negative x, the denominator doesn't change, but the numerator will to the opposite. So I can already say, and I think, again, I would never say who, and I don't even remember, but someone said,
For the sake of the security.
if it's not odd, it's even. No, you cannot conclude. If the function is not even, you cannot say that it's odd.
Oh, that's old.
So, because the function may be odd, there is a function, which is not really a function, but it's a function in a way, that is odd and even at the same time, which is y equals 0. Y equals 0 is the x-axis, which is a function. Y equals 0 is a function. Who cares about it? No one, but it's a function. And it's symmetric with respect to the y-axis and symmetric with respect to the origin. This is the only one that is odd and even at the same time. No other function is odd and even, but the function doesn't have to be symmetric. If I say it's not odd, I cannot automatically conclude that it's even.
The great thing about y is equal to 0 is it Rolle's theorem applies to it everywhere.
Rolle's theorem.
Right.
Are you confused about what Rolle's theorem is?
No,
This
but
was always saying-
but I'm confused on how y equals 0 complies with Rolle's theorem.
Because f
Because it's continuous everywhere, and
Always.
it's differentiable everywhere,
But where do we use that?
and it
Okay, good.
contacts the x-axis.
Domain.
Get back to the problem.
All real numbers except negative 1.
Very good. So yes. So what I recommend, just create the chart, put f prime if you're using this chart, you don't have to use it, and put f double prime, and just do this. Because if the function is undefined and negative 1, so will its derivatives. So that's my starting point. So undefined and negative 1, undefined at 1. Because there is no way I can simplify this x plus 1 and x minus 1, they will not be holes in the graph. But if I have something like this, negative x, x minus 1 over x minus 1, x plus 1, function is still undefined at 1, but this x equals 1 is not a VA. It will be an open point. The remaining one has to be a vertical asymptote. But this is not our case here. But please remember. Okay, so then I know that since x plus 1 does not go away and x minus 1 doesn't go away, what do I know? That x equals negative 1 and x equals 1 are automatically vertical asymptotes. Correct? Okay, perfect. So domain and vertical asymptotes right away. Now I need to determine this, 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 and this.
They all look like constants.
Yes. Please.
Limits.
Yes. All these limits. 1, 2, 3, 4, 5, 6 limits. Please. 2 minutes.
Let me also.
You have sharpened
We wanna do the
pencils,
X and
so
Y
let's
intercept.
say it again.
Don't we want to do the X and Y?
Yes, of course. So I'm focusing on the function. Yes. X and Y intercepts, limits, asymptotes. Yes.
I've looked carefully, but I can discern no markings.
What's the function?
Oh, he doesn't have a pen.
I don't have a pen. I have an erasable pen.
So what are we determining?
plus is plus.
The limit as x approaches negative infinity.
Very good. Limit as x approaches negative infinity from negative x over x squared minus 1. This is the better form for this situation when I determine the limit. So what is the limit?
0.
Perfect. So this is 0.
It's the same thing.
Very good. I agree. And also when x approaches infinity is the same. What do I conclude now? That
It has a horizontal asymptote.
y equals 0 is a horizontal asymptote at both sides. Excellent.
That's interesting.
Now, I'm not finished. I have to finish this. So, what do I determine next?
Limit as x approaches negative 1 from the left, and limit as x approaches negative 1 from the right.
Very good. Now, this is the better form for those limits. This is a better form for limits left and right of the vertical asymptotes. So what is this? The numerator has what sign? I know it's a number over 0. Do you agree?
Yes.
So I know there is no hope. It's a vertical asymptote. So I have to get infinity, some sort of infinity. So with negative 1.1, what is the sign of the top?
Are we counting the negative on the outside? as
Of
part the numerator?
course, yes.
Okay. Okay, positive.
What is the sign of with negative 1.1 of this?
It's a
Negative.
That's negative and negative, so
So,
positive infinity.
very good. Now limit as x approaches negative 1 from the right of negative x, x plus 1, x minus 1.
Negative.
So the top is negative, bottom,
The top is
top is positive. This
That's
is positive.
One's
And
negative.
that's
So
negative.
positive, positive, negative. I agree.
Negative.
What does this mean?
They'll undefined.
Yes, vertical asymptote, right? X equals negative 1 is a VA, which we already knew. Since I know that f of negative x equals the opposite of f of x, I know that the function is odd.
That's odd.
Knowing that it's odd, I should be able to determine these with no calculations, just from the fact that I know that it's odd.
Negative infinity. Positive.
Well, that will be even,
You switch it from negative 1.
right?
Oh,
So positive infinity to negative infinity. What happens at 0? Perfect. Is there anything else that I can find about the function from the function itself?
not current.
That's true. That it's done. I exhausted everything. Domain, asymptotes, limits, x and y intercepts.
Don't you feel exhausted?
Next. What do I have to do? So the function is negative x over x squared minus 1. What now?
Derive it.
Exactly. So f prime of x. Leave the negative outside. It will wait for you patiently.
X squared minus 1
The top function prime is
is 1.
1 times
X squared minus 1
minus the first function multiplied by,
2x.
very good, over,
X squared minus 1 all squared.
perfect. So negative outside, I have x squared minus 1 minus 2x squared over x squared minus 1 squared.
So that's going to be negative x squared minus 1.
But now, it is wise to put the negative back up.
Yeah.
What do I have at the top?
X
How
squared
did you do
minus
that?
1 over x squared minus 1.
Negative
Square
1
out.
times this is positive. Negative 1 times this is positive.
Well, you actually get 1 over x squared minus 1.
No, because x squared plus
Oh.
plus u are not the same.
We had the first need.
So now, what am I looking for? I determined the first derivative. Now what? I'm trying to find what? Very good. So I have to say f prime is 0 or f prime is undefined.
Well, f prime is undefined at negative 1 and 1, which we already knew.
Exactly. So no critical number will come from here.
And it's 0
What about
nowhere.
nowhere? Do you all agree that so a fraction is 0 when the top is 0? Can x squared plus 1 be 0? No. So
Well, not
I'll
at
say
any real number.
no critical numbers. Now I go back to my chart. Can anyone tell us the sign of this expression? Always positive. Excellent.
I was trying to calculate the function sign.
So now I have to make sure that the two rows work well together.
0 to
From 0 to infinity, what does the function
it's
do?
going up.
Is that supported by the sign of the first derivative?
They're all going up.
From negative infinity to 0 to infinity. Okay.
Disney movie.
And from negative infinity to 0.
Up.
Good. What is the next step? Second derivative. Very good. So the second derivative. Ready. I already know the inflection point. But let's find the second derivative. Please dictate.
Second derivative is 2x times x squared minus 1 squared minus 2x squared minus 1 times 2x.
Excellent. Now if you start multiplying, taking to the second power and distributing, you will never finish. What is the key word right now? Don't touch it. What is the key word? I thought you said that. No?
I said luck. I was joking. We're finding correct numbers. Let's find something to cancel out.
Right, so how do I do that?
Simplify.
See if we can take anything
Multiply
out.
everything.
Exactly. The key word is factor. If you don't factor and simplify, you will never finish.
It's a big factor.
So let's do that. What can I factor out from the numerator?
X squared minus 1.
X squared minus 1 is 1, and also 2x. I completely agree.
So you get 1 minus x squared plus
So 2x is out. One of these are out. So what is left?
x squared minus 1 minus x squared plus 1.
So 2x is out. X squared minus 1 is out. So I have to distribute 2 to these two terms with the sign in front. What do I write?
Minus 2x squared minus 2.
Good. Any questions so far? What do you think I'm going to do next? Yes. First of all, I'll remove one of these. Look how easy it is in comparison to that. So please, this is crucial. Factoring. Factor out. Okay? Good. So then we have 2x. Then this is negative x squared minus 3 over x squared minus 1 to the third. Yes, I will factor out what? Yes. So then 2x, x squared plus 3 over x squared minus 1 squared
To the third.
and x squared minus 1.
Why did you
which portion of this I should not even consider plugging in anything?
-1.
The first part of the denominator.
Yes. This is always positive. I wouldn't worry about it. So now the second derivative is 0 when x squared plus 3 is always positive.
When x is negative,
When x is
but not negative.
Wait, what?
Oh,
when is this fraction 0?
when x is 0.
When x is 0, correct. So I go back to my chart right here at 0. But now I have to study the sign of negative x over x squared minus 1. So the sign is only given by this. So pick a value like -3, plug it in and tell me the sign.
-3. I think that's the value you should use.
So the top is positive and the denominator is
It's good to stick.
now I'm going to try to plug in a value that is -0.5. -0.5 with minus in front is positive, but -0.5 squared minus 1
It's
will
negative,
be,
so everything is negative.
now I'm trying 0.5. 0.5 with minus in front will be negative, and 0.5 squared minus 1 will be,
Negative, so that's positive.
so that's positive.
And then the next one is negative.
Yes, because it's a odd function. Good. No max min. However, 0, 0 is, I should say 0, 0 is,
Is
The x line or so.
yes, and also when the second derivative changes sign,
it's an inflection point.
it's an inflection point. So this is an inflection point. Good. So now I'm ready to graph.
You do that by the time. Let's say
So when I graph a function with asymptotes, what do I have to graph first?
the asymptotes.
Good. This function has 3 asymptotes. Has y equals 0. And x equals -1 and x equals 1. I read my chart.
If you can kick the football screen.
It's coming from 0, increasing to positive infinity on the left-hand side of the first asymptote. From 0, going up
Curving up.
to the left-hand side of the first asymptote. In the middle, it's coming from negative infinity, increasing to 0, increasing to positive infinity, and it has an inflection point as well as x and y intercepts at that point.
So you can't.
And it's opening down and it's opening up in the middle. Finally, it's increasing from negative infinity to 0,
Curve down.
opening downward.
This looks
Function
familiar.
is symmetric with respect to the origin, and this is f of x equals -x over x squared minus 1. Any questions? Yes. Any questions? You will have a problem like this. Are we going to work on another, or we move on?
Let's cover another one.
Okay.
Something else, so just cover more ground so we can have more choice.
Okay. Very good.
Run fast, cover ground.
Let's say problem 20 on page 352. And that is y equals x to the third minus 6x squared minus 15x and plus 4. Everything, like we just did.
Graph that.
Please.
Oh my.
If you need help, let me know, please.
We're supposed to be able to factor this.
If it's not factorable, then you have to find the solution somehow. No, it's not factorable, but you can find the solutions with a graphing calculator.
That probably helps.
How many solutions will you look for at the most?
3.
Exactly. It is possible that a cubic function only crosses once. It's either once or 3 times. Does anyone need help? Now, if you want to graph this function, just because we need to find the x-intercepts, so we have x to the third Bless you.
Bless you.
Thank you.
-6x squared. Minus 15x
Just a shot wave.
and plus 4. And I would use the standard viewing window for the beginning. Now I know that it crosses 3 times, no doubt about it. So one intersect is somewhere around -2, another one close to 0, and another one close to, what is it, 2, 4, 6, 8? So here's how I determine those intercepts. With second and calc, I go to intersect or 0. If you want to use intersect, the second function has to be y equals 0. But if you want to use the 0, that's even better, and press enter, it will ask you where, or give a left bound. I see it's -2. I'm going to say between -3 and -1. -3, -1, and no, I don't want to guess. Just give me enter. So it gives us -2.09 and y equals 0. So let me write these down. -2.09 comma 0. Then I see the next intercept is between 0 and 1. I'll go back to second and calc, and I want 0 again. So between 0 and 1, and I don't want to guess. So it's giving us 0.24.
So what is this guess function?
It's asking, no, you don't have to, you can guess. If solutions are very close to each other and you guess, the calculator knows more details about the one that you want.
Which one you want.
Exactly. So I see that the other one is around 8, so I'm going to say between 7 and 9. So second and calc and 0 between 7 and 9, and press enter, and it's 7.8. So 7.8 comma 0. So this is how we
Really?
find, I'm sorry?
Because it says y is equal to 2.
That is 0. E to -11 is 0. It's a tolerance of the calculator. All calculators have some error. So we have the x-intercepts. We determine the x-intercepts. Do you need help with anything else? Okay.
Could I see the zeros again?
The ones you wrote down.
-2.09 comma 0.
I'm sorry.
That's okay. 0.24 comma 0 and 7.8 comma 0.
-2.
What is the domain of this function?
Or real numbers.
Of course. Why?
Because it's a polynomial function.
Excellent. Wonderful.
I got that right. Question.
Yes?
Do we have to plug the zeros for f of x into f prime x?
No.
Okay, so we don't have to plug a lower derivative function into a higher derivative function. We do have to plug these zeros up, for example, f double prime, back into the last two functions.
Yes.
Thank you.
What are the limits at infinities?
It's -3.
Of course. Which we knew from pre-calc, because the leading coefficient was positive. Good. Is there anything else we need or can find about the function from the function itself? So here's what I put. The limits at infinities. I put -2, roughly 0, 0, 4, 0.24, 0, and 7.8, 0. Do you all agree with this step so far? What are we determining next?
F prime.
Please. And after we determine f prime, what are we going to do? Find critical numbers. Can critical numbers come from f prime being undefined?
Yep.
Yeah.
Except
No.
no, because
Because
it's a
even
polynomial.
f prime is a polynomial. Good.
Is the derivative of a polynomial function always a polynomial function?
Yes, please.
Okay. That is useful information. Is ln of x considered a polynomial?
No.
Isn't the derivative of 1 over x?
ln x is not a polynomial
No, the ln of
because
x derivative
ln
1
is
over
not defined everywhere. Number one. ln has a vertical asymptote. Polynomials don't have.
x. Wait, is the derivative of 1 over x ln of x? Or is it the other way around?
The other way around. The antiderivative of 1 over x is natural log.
Okay, so
The
derivative
integral of 1
ln
over
of
x is
1
natural log of the absolute
So
value
this
of
stuff
x.
is messing me up.
Yes, you have to be careful on that.
Okay.
So how much is f prime?
F prime is 3x squared minus 12x minus 15.
3x squared minus
I can give
12x
you f
minus
double
15.
prime as well.
I need critical numbers first, and then we look at f double prime. So what will you do? You will write f prime of x is 0, which is 3x squared minus 12x minus 15 is 0. And what will you do first? Exactly. Thank you. Make your life easier. Divide both sides by 3. X squared minus 4x minus 5 equals 0. And this is much easier to factor. How? Very good. X minus 5 and x plus 1. And now x equals and x equals. Good. So now I will put these values 5 and 0 and -1 and 0. Yes, I need to study the sign of the derivative. Please plug in -10 in the derivative and tell me the sign. Then plug in 0 in the derivative and tell me the sign. And then plug in 10 in the derivative and tell me the sign. You shouldn't have to do anything like that because you know that this is a quadratic function with a positive leading coefficient. So it's negative in between and it's positive outside. Correct. So negative and positive. Now this is a key moment because this is the time when I catch my mistakes, if I have any. These two rows, if they don't work well together, then I know I have a mistake. Before that, I have to determine this value. And I have to determine this value. So I have to plug in the function what?
-1 and 5.
Exactly. So I have my function right here. I already have it in the calculator. So I go to second and table, and I plug in -1, and then I plug in 5. So I got 12 and -96. 12 and -96. Now, this is the moment of truth. This is very important. I have to see and show that these two work well together. Ready? So, from -infinity to 0, what does the function do?
Goes up.
Is that correct?
Yes.
From 0 to 12?
No.
From 12 to 4?
No.
From 4 to 0? From 0 to -96? From -96 to 0? And from 0 to infinity. Now I will identify at this moment the max and the min. What point is -1, 12?
Local max.
Local max, up and down. Local max. What type of point is 5, -96? Now I'm ready for what? The second derivative. Can anyone dictate the second derivative? 6x minus 12, which is 6 times x minus 2. When I set this equal to 0, I will get x equals 2. I didn't plan ahead. I have to insert a 2 in here. And then I have to find the value when x is 2. I'll find it right now because I'm right here. To enter -42. So what is the sign of the second derivative? Plug in a number between -infinity and 2, and then plug in a number from 2 to infinity. But I already know how to graph this.
Negative.
Exactly.
You just enjoy doing this.
I know I look silly, but as long as you remember something about that, that's fine. So 2, -42. What type of point is 2, -42? Very good. That's an inflection point. Ready to graph it? Ready? I only need my chart. Of course, the function is not symmetric. I only need my chart. Nothing else matters. Good. So I have to plot -2, 0. Have to plot -1, 12. I'm going to say this is -1. Oh, -1, 12. Sorry about that. Because I was counting and then I stopped counting and
Now we have a hole. We need to learn how to count in calculus class.
yes, yeah, it will. Yes, it will help. Yeah, good. Then I have 0, 4. Then I have 0.240. Then I have 2, -42. And then I have 1, 2, 3, 4, 5, -96. And then I have 7. This was 5, 6, 7, 8. Okay, ready? From -infinity goes up, crosses at -2, 0, continues to go up to this point, which is a local max. Then it starts decreasing, crossing the y-axis at 0, 4. It decreases, crossing at this point. It continues to 2, -42, where it has an inflection point, where it changes concavity. Oh, yeah, I'm sorry. I wasn't graphing it correctly. It opens down. Yeah, because this point is further, much lower here. So it's still opening down, and now it opens up.
And actually bubble.
So I'm going to graph it one more time so you can see it.
This time in green. That's a. I feel sorry for your highlighter. It's not that easy.
So here's the inflection point. Here is local min, and here's local max.
And they're both local max as well.
So this is opening down, but it's not perfect because this is much further. much lower, and this is opening up. Good. Go back to chapter 4. Okay, other problems? Are we okay with this? Okay. I would like to look at a problem like, let's say 16. On page 352. Ready? We are told, sketch the graph of a function that satisfies the given conditions. And here they are. F of 0 is 0. F continuous. F even. F prime of x is 2x for x between 0 and 1. F prime of x is -1 for 1 between 1 and 3. And f prime of x is 1 for x greater than 3.
What do you got?
So we have to graph a function that complies with all the given conditions. We have 1, 2, 3, 4, 5, 6 conditions. So let's think about it for a moment. And then I'll tell you what I would do on such a problem. Yes, Ian? Yes.
Wouldn't it be a piecewise function?
If it's a piecewise-defined function, as long as but it says f continuous. I can. Yes. It also says f even. Yes, it's very possible. As long as it's continuous and even, yes. Yes, piecewise defined functions can be continuous. Absolutely. Are we thinking about this? Okay. 2 minutes. That's true.
We're only graphing it from 0 to infinity
Yep. But it has to be even.
because it doesn't. Oh,
It has to be even.
because
This is what we have the information on one side, but it has to be even. And then I will like to look at the Newton's method. And an optimization problem.
it looks like an upside down, really weird face. You okay?
Mhm.
You need water? I have some.
Man is prepared. His Cheerios and water.
I actually ran out of materials. I finished it.
Yeah.
I'm gonna have to stock back up.
This is a sure sign of the apocalypse.
Yeah.
We caught Anthony without you.
Okay, got it. Got it. Okay. Good. So let's do this together. Here's what I would do. Okay. Okay, so I go step by step. I put in this condition already. Now I have to remember these. I cannot forget these conditions. So now I'm given between 0 and 1. Between 0 and 1. The derivative is 2x.
Oh, take the antidote.
No.
It's gonna approach.
No. No. F prime of x is 2x. We don't have integration in chapter,
Oh, it's
right?
prime.
Okay.
Oh,
So
okay.
f prime of x is 2x between
oh,
0
it's
and 1,
never here, right?
which means that the function, the derivative is positive, which means that the function is increasing. So f prime of x is 2x between 0 and 1, which tells me that since it's a positive number, it's increased. Since x is between 0 and 1, the function, the derivative is positive, so which means the function is increasing.
We're not supposed to
I'm
use
done with
integration
that.
at all.
I'm sorry?
Just try- We're not supposed to use integration at all because at this point we're not supposed to know that, so we shouldn't like. throw that
We're
into
not
the
asked to
story.
find the function. We're asked to graph a function that complies with these conditions.
Right,
We're not
but we
asked to find
shouldn't- We shouldn't use integration to make it easier. For
No, you can't.
Okay.
You
'Cause
cannot.
I was gonna be
You
like,
cannot.
well,
You
that's
cannot.
X squared, and then.
Okay? So, between 1 and 3,
Oopsie.
the first derivative is -1, which means the function will be decreasing. And I'm done with that as well. For x greater than 3, the first derivative is 1, which means positive. So then the function is increasing. Don't forget, this is a continuous function. So what does this function have at 1? Local max. What does the function have at 3? I don't know what it is. I have no way of finding it, but I know that this will be a local max and this will be a local min. So I'm going to graph what I have. So I have 0, 0 for sure. That is clear. 1, 2, 3. So at 1, so I don't know, and I'm not told, and I don't have to think of concavity. As long as I graph a function that is even. I'm not told anything about the second derivative. Who cares? So at 1, the function has a maximum. At 3, the function has a minimum. So it's increasing. And it's decreasing to 3. And then it continues to increase.
If the function has a constant slope, it's not going to have
Now,
that
on the other
constant-
side, I have to have the same points. So this point at 1, yes, 1 second.
If the function has an integer for its slope, it's not going to have the curve
If it has an
that you
integer.
have between 1 and 3.
Oh, yeah, that's true. It has to be constant. Thank you. Absolutely.
Also, it's going to curve up on the 2x because it's small values going to larger values. So it's going
Between
to-
0 and 1.
Yes.
It's gonna be an exponential growth instead of
So, yes, so
It's going to look like exponential growth and then a straight line.
exactly. I forgot that they were constants. I should have written them here. I should have written this that f prime is -1 and f prime is 1, so I don't forget. Thank you. Okay, so between 1 and 3, the function has a slope of. I will have to graph it again.
Yeah. Well, you could just apply it to the other side.
No, I'd rather start from scratch. So 0, 0.
It curves up like exponential growth to 1. So it I'm not remembering the words for it.
So between 1 and 3,
It is a straight line because it has an integer for
slope of -1, and then slope of 1. On the other side, it has to be even. I made it cross here, somewhere in the middle. And then going up.
We made a volcano between mountains.
This is not the only function. So this is one possibility. Very good.
Yes.
Thank you. Okay, let's look at the Newton's method.
Oh my.
We're asked to solve the equation x to the fifth minus x to the fourth plus
X to the third.
3x squared minus 3x minus 2. And this is problem 62 on 353. Very good.
I don't remember which one Newton's method was.
Okay, here's Newton's method. Xn plus first xn minus f of xn over f prime of xn. With the intermediate value theorem, you have to find an interval. It has to be a unit, unit length. And then you start anywhere you want, but f prime of x0 should not be 0. Ready? Is it okay?
I'm just trying to remember.
Okay.
We're all just
You
trying.
can, sorry, like,
Okay, so let's work on this for 2 minutes, please.
is this to find, what are we trying to find here?
The solution of the equation. One solution
Like what x equals?
to make the left-hand side equal 0 is an x-intercept.
Right.
Are we working on this? Please.
I don't know.
You will have to use the intermediate value theorem to find an interval of unit length in which the function crosses the x-axis. A function is continuous, therefore, if it's positive and negative at the end of a unit length interval,
Then
Then
it must be 0 somewhere.
it must be
into
0 somewhere. Exactly. Excellent.
A good move would be to graph it on a graphing calculator to see
You have to do that.
to see if you can find a place
Correct.
where it
Please.
applies.
Yes.
You're supposed to do that?
Well, it would be easier to
It's
find
easier,
the
and
value.
you don't have to graph it, but it's easier if you put in the graphing calculator and you punch in numbers. And you see where it changes sign. So you have to do that. So let's work on this so we can accomplish more, not just a couple of problems, please. So please put the function in the graphing calculator in y equals and start punching in numbers and see where it changes sign. Because the function is a polynomial function and it's continuous everywhere. Have we found an interval
Between 1 and 2?
between 1 and 2?
Mhm.
Very good. So we can say by
By the
the intermediate value theorem, f constant, I'm sorry, continuous I meant to write, and I did. And f of 1 is positive or negative?
F of 1 is negative,
And
f of 2 is positive.
Perfect.
Hence,
So therefore,
f of
there
x.
exists c in the interval 1, 2. And this is the c that we want to approximate, let's say, with 8 decimal places.
So is there a good place to start?
It
Which
doesn't,
one do we pick?
as long as f prime of that number is not 0, you can start either way, in other direction.
Okay.
So, what do we do next? We have to find,
Do we take the prime?
yes, so our f of x is x to the 5th minus x to the 4th plus 3x squared minus 3x minus 2. It is imperative that you would go home and redo all tests with solutions between now and Thursday, at least once or twice. Please. Please. I will post solutions when I get to my office
All of the
tonight. So then f prime of x is
5x to the 4th minus 4x to the 3rd plus
plus
6x.
6x minus 3.
now you can start at 1 as long as when you plug in 1 is not 0. 5, that's 11 minus 7, that's good. So you can say I picked x0 to be 1. How do I determine x1?
1 minus
F of
over
1
f prime x.
over f prime of 1. But instead of doing this, what did we say? We created a function, let's say g of x. Which function did we create?
F of 1 over
X minus,
x minus f of x over f prime of x. And so we just created a function that we can plug stuff into.
exactly. So let's do this. Let's put in this function in the graphing calculator, please. Don't forget parentheses for the top. If you omit parentheses here and here, you will get,
Weird answers.
yes, although some calculators don't need that.
Oops.
So in y equals, clear, and put parentheses, I'm sorry, x first. X minus parentheses, x to the 5th,
X to the 5th minus x to the 4th plus 3x squared minus 3x minus 2. Over 5x to the 4th minus 4x to the 3rd plus 6x minus 3. 4x to the 3rd plus 6x minus 3.
Thank you very much. Ready? So
You're good.
now with second quit,
Don't quit.
no. Although it's better if I just go in there and,
It's good.
or better, no, better is with this. And we plug in 1. Then I go back to the same thing.
That seems to take a long time
No, the previous answer.
to go back to the function every time.
Oh yeah, I can just do this.
You can do
I just press
I
enter again.
believe it
Can
also
you
works
have
if you
this
just keep hitting enter.
Hmm?
If you just keep hitting enter, I believe it works as well.
Yeah,
Thanks.
like second and entry, right?
I think you
Yeah,
just
you
press
just
enter.
Yeah.
Just plain enter without anything
So 2 decimals, 4 decimals, I'm at the last 2. Because I wanted 6, oh no, I wanted 8. Oops.
Hopefully.
I got 8 right here. So the solution is 1.29738342468440.
If you go alpha solve, it just does the same thing again and solves.
So x is 1.29738340.
That's good.
Any questions? Any questions? Okay, so this was 11, this is 12, 13. Okay, perfect. I'd like to choose an optimization problem now.
I just have a question.
Yes,
Can we have a list of topics to go over?
yes. Everything that you had on tests. But yes,
All the above.
yes, just everything that you had on tests. But I can make a list if you want.
Okay.
No
Well,
problem.
I can write it down. But I'm just like,
No, it's a long list. I don't want to spend that time right now.
at the end of
let's
class, if we could.
Yeah. You want it today, or can I bring it to you on Thursday?
I should just email it to you.
It'd be kind of hard to bring it to me on Thursday.
Oh, because you're not going to be here. Okay. Okay. So let's work on one optimization problem, and then I'll make a list.
No, I can wait after a little bit.
Could you just post it on Canvas for everyone to look at?
Say it again.
Could you
Yes.
post it on
Yes.
Canvas then?
Yes. Is that okay? Can I put it in Canvas?
Yeah.
Okay.
I have access to Canvas, which is
Okay. Very good. 58
the relief that I felt.
on page 353. A metal storage tank with volume V is to be constructed in the shape of a right circular cylinder.
Alright.
A right circular cylinder, basically a cylinder with a circular base. As opposed to a general
Surmounted by a hemisphere,
base.
which is this. What dimensions will require the least amount of metal? Minimize
What's the thing on top?
half a sphere.
Okay.
Minimize what?
Minimize the
Surface area.
amount of
Which is what?
Material.
Yes, which is what?
surface area.
Exactly.
You said it first.
Oh, I didn't hear. I'm sorry. I'm sorry. Forgive me. Sorry. Sorry.
I'm not going to
Sorry.
take.
So we know that that bless you.
Bless you.
We know that these two have a volume of V. So half a sphere plus the cylinder have a volume V. Say it again.
Not counting the top.
Including the top,
Of the
yes.
cylinder.
Yes,
Because it's
that's
shareable.
half of a circle, half of a sphere,
Mhm.
and then the cylinder.
It's like adding.
But when
It's
I-
like adding integrals together because if it's undefined, you're still putting two area numbers together.
No, because there wouldn't be like metal there, because wouldn't that all be connected? Or no?
Yes, there will not be a lid. Yes.
We're assuming that the top of the cylinder is infinitely thin.
I would assume there isn't any. It just
There is no divider between the half of the sphere and the cylinder.
So shouldn't we not count the top of the cylinder as
As-
surface area?
Of course,
Surface area,
that we
yes.
should not.
Okay.
Okay, ready? So now, first of all, let's find a function that represents the area of the cylinder and half of the sphere. Okay. So I'm going to say the area of a cylinder plus the area of a sphere, which is half a sphere. Now, in order to determine the area of the cylinder, I have to have a height and I have to have a radius.
Well,
The radius is the same radius as for the sphere.
The same radius for the sphere, exactly. Good. So then, let's think. I have a cylinder here. So there is an area of the base, and there is the surface area. What is the surface area now?
Rectangle.
So it's, what is
it's
this?
the circumference.
Is
times
the
height.
circumference times the height. We agree?
Yes.
Perfect.
Now I have to think about
So
spheres.
now the cylinder will be pi r squared plus 2 pi r times h. Area of the base plus the exterior. Would you
Shouldn't
agree?
you just do 1 pi r h? Or the pi r h is for the
Okay.
top and bottom, isn't it?
So not the
Pi r
top.
squared
There
is
is
for
no top. There is no top. So it's
That's
just
what I'm
one. So
Oh no,
Oh wait,
never mind.
you're doing surface
so
area,
this
not volume.
this is 2 pi r and this is height. So the area of this will be 2 pi r times h.
Okay, so that's
And,
the
and
we're
the-
good.
So
the
so
circle
far.
on the bottom is-
Now how do I determine the area of the sphere? It's a half a sphere. But how do I determine the how do I
Pi r squared.
remember? How do no, no,
Height.
please, please, please.
I don't know this.
Let her
Okay.
talk.
Do we know the volume of a sphere? 4/3 pi r cubed. For the area of the sphere, we only have to differentiate this with respect to r. So please remember the area of a sphere is the derivative of the volume of the sphere. So if I bring 3 down, what will be the area of the sphere?
4 pi r squared.
But since it's 1/2, so I'm going to put 1/2 4 pi r squared.
Oh,
Does that work?
I'm noticing that on
I'm
top.
sorry?
I'm noticing that on top that the circle and the base of the cylinder, the circumference function as opposed to the area function, one is the derivative of the other. The pi r squared and 2 pi r.
Does that work for all normal shapes, like the volume? If you take the derivative, it's the surface area.
And then if you take
Not
the
necessarily,
derivative,
not
it's
necessarily.
For all normal shapes?
Not necessarily. A cone, for example, is not going to work like that.
How do you know if it will work?
Because first of all, you have 2 variables in there.
Like if it's like a sphere, would a rectangle work?
For a rectangle, well, if you, for example, yes, Ian?
Well, before you answer that question, so if there's one variable for the volume of an object, if you take the derivative, then
I have to look at the object. I'm not sure. I have to look at it.
such as a
I
square which
can
had
draw.
one variable for
I can-
all of the side lengths.
I have to look at it. So here's the area. It has 2 variables, r and h, right? So the area right now will be, when I simplify by 2, I have 2 pi r squared plus another pi r squared, which is 3 pi r squared. And I have also 2 pi r h. I know the volume now. I have to work on the volume of this figure. What is the volume of the cylinder? Very good. So pi r squared times h plus, we already know the volume of the sphere, but it's only half of it. So it will be 2/3 pi r cubed. Okay,
Yay for
so I have the area, but it has 2 variables, and I have the volume. And this is given to us. R and h, of course, are not. So what should I do next?
Relate them. No.
So this is given.
One of them,
I am trying to find a function that has only one variable.
you have to
Yes.
use one to get one variable. Don't
Yes,
you
which-
use v,
You have to
Yes,
say-
in order to solve for what?
h.
Very good, excellent. So I will solve this equation for h. From here, I get h by itself. So then v minus 2/3 pi r cubed equals pi r squared h.
divide everything by
Therefore,
pi r
h will be v
v minus 2/3
2/3 pi r cubed over pi r squared. If you want, you can separate it into 2 fractions. So h will be v over pi r squared minus pi will go away and 1. So 2/3 r. So this is h. Now I want to do what with it? Where am I going?
Substituted into area.
Substitute it right here into the area.
How does that work with the v?
V is given. V is given. R is the only variable now.
Okay.
So then I have the area, which is a function of R only. S 3 pi R squared plus 2 pi R multiplied by V over pi R squared minus 2/3 R. So therefore, I will distribute 2 pi R and see what happens. So a function of R is 3 pi R squared. Pi and R will go away, so plus 2V over R. And then I distribute here, and I get minus 4 pi R squared over 3. I will combine these two. So A of R equals 9 minus 4
5 pi r
Five.
squared
over 3 plus 2V over R. Okay. After all this work, I was able to determine or find a function, which is the area. And what am I going to do next? Very good. So I have A prime of R, which is, bring 2 down, 10 pi R over 3 minus 2V over R squared. Because I need to set this equal to eventually to yes, I have to find the least common denominator, which is 3R squared, to multiply this by R squared and this by 3. So I have 10 pi cubed minus 6V.
Is v given?
Yes, it is, but only in the form of V. So now, what will I do next? I have a function that is the derivative, and I need to set it equal to 0. So A prime of R set equal to 0. When is a fraction 0? When 10 pi R cubed minus 6V is 0. What do I have to solve for first?
R.
Cubed. So 6V over 10 pi. And now I solve for R by taking the cube root, but I simplify by 2. So 3V over 5 pi. This doesn't mean anything, because I did not convince you. A prime of R. I did not convince you yet that this gives a minimum.
We don't have to plug something in for v.
I have to, I'm sorry, no. So I have to go back to this. What is the sign of the denominator so I don't have to worry about it? Positive. Okay. So now let's say I plug in a number here to the left-hand side of this positive number, like 0. Is the volume a positive number or a negative number?
Pretty much always a positive.
So times negative divided by positive. What will be the sign of the expression here? On the other side, let's say I consider R to be V. Impossible, but I'm here, right? So 10 pi V cubed minus 6V, what type of number will that be for sure?
Bigger.
So now I convinced you that this is giving the local minimum. Any questions?
No.
So you don't really need to plug in anything for V.
That's because we weren't given any
I
values.
consider, exactly, I consider 0 here and V here. Because definitely the cube root of 3V over 5 pi will definitely be smaller than V. So when I plug in 0, I get a negative number. When I plug in V, I get positive. So this must be exactly what I'm looking for. So R equals the cube root of 3V over 5 pi gives the minimum material area of the material, which is the same thing. That's what I meant. Any questions? Any questions? Okay, well, I'll stop here for tonight. We have 2 minutes left. What I'm going to do is on Thursday, I'm going to continue reviewing, going back to limits, L'Hopital's rule, Rolle's theorem, intermediate value, mean value theorem. And back to the first few
Yes, that's
lessons.
fine.
Thank you. If you have any questions, please stay.
Thank you if you have any questions, but if you don't have any questions,